First, we measured the total height of the sediment in the jar. Overall, we found that the total height was 3.302 centimeters. Here, we measured the sand, which was 1.27 centimeters, the silt, which was 1.905 centimeters, and the clay, which was 0.254 centimeters. Here, you see Lauren is placing masking tape on the jar with sand, clay, or silt to determine what type of soil is being represented. Overall, with a total height of the soil, which was 3.302 centimeters, 37% was sand, 56% was silt, and 7% was clay. With 7% clay, 56% silt, and 37% sand, we found that the soil type determined is silt loam.
The structure of soil is important because soil contains many nutrients for plants to grow. If soil is fertile and structured, then crops can grow, but if it is not structured and fertile, then it will not be able to sustain life. Soil structure is also important due to the fact that soil lays the foundation for many structures, and if the soil is not dense enough, then it cannot bear the weight of the structure above. For example, in any beach town, many of the houses are raised up above on stilts. This is due to the fact that the primary soil type is sand, a non-dense soil. So if the house were to be placed directly on the sand, then the house would eventually sink and move. To classify our soil type, we use our knowledge in the soil triangle. After figuring out what percentage of sand, silt, and clay were in our jar, we could then refer back to the soil triangle and then determine that our soil type was silt loam.
Our results by feel were not as accurate as our results by the hydrological cycle. However, looking at it through the soil triangle spectrum, both tests were located in around the same location. There were minor differences with the percentages in each soil type. By feel, we determined the percentage of clay to be 10%, whereas through the hydrological test, the percentage was 7%. This change in percentage applied to silt and sand as well. By feel, the percentage of silt was 50%, where the hydrological test was 56%. And by feel, the percentage of sand was 40% and 37% by the hydrological test. I believe that the hydrological test is more reliable and more accurate than the field test.
The soil triangle is used to display the proportions of silt, sand, and clay within a specific type of soil. As shown by the soil triangle diagram, you can see that if you were to take 60% clay and 50% sand, as well as 70% silt, you will match up at clay foam. The most common characteristics of soil in this area are typically that the soil is mainly made up of clay. Soils in North Carolina are typically characterized by large amounts of clay, and septic tanks would work well as they hold wastewater and allow oils and water to float to the top while substance sink to the bottom. Clay would just take a little bit longer time to sink to the bottom since it's small particles.
The chemical composition of soil is what determines plant growth. According to the Agriculture Victoria, plants cannot survive without essential nutrients from the soil such as nitrogen, carbon, phosphorus, magnesium, and sulfur. These chemicals in the soil also determine the soil's pH and salinity. Soil is also composed of inorganic particles. These particles contain many minerals that can be broken down into nutrients for plants. In addition to inorganic particles, soil is made up of organic matter. Organic matter greatly affects the soil's structure and water holding capacity. Soils that have a great amount of organic matter have good structure, good water holding capacity, and less soil erosion. Some of the possible errors in this lab could have been taking incorrect measurements. For example, it was difficult to precisely measure the height of how much sand, clay, and silt was in the jar. One reason could be because the water seemed to be the same color as the sand, clay, and silt.